Hello students and welcome back to Mechanical Engineering Practice and Graphics. This week we will be covering the chapter number 4 of the book, adding relations and dimensions to sketches. Now for this week we have a couple of announcements. The first one is today it's Monday, February 8th, and tomorrow, Tuesday, February 9th, we will have the first quiz. The blueprint for this quiz is gonna be available for you at midnight today. So you will have tomorrow all day long to finish and submit it to Blackboard. The deadline is tomorrow at midnight. So if you go to Blackboard in the folder of the lab, and then you go to content, then you go down to sections 3 and 4, our sections. You will find the folder for week number 4, and actually I have some comments there that this week we're gonna have quiz. In this folder you will find the blueprint. You will have to submit the Solidworks, do the part in Solidworks and submit the Solidworks part file and the PDF file with the screenshots of your progress to this location here. And then the file of the quiz will be available for you tomorrow at the first minute of the day. And the quiz is gonna be due tomorrow at midnight. So you will have the entire day to do that. Also, in this same folder, I will upload the homework 3 for this week. So this is the quiz. I'm not gonna open it now, but you will be able to open it tomorrow at first hour, and that's it. Then when you finish, just submit everything also to Blackboard. That leads me to the second announcement, and is that next week we will have the first midterm. That midterm is, if I recall correct, 15 or 20% of the final grade in the lab. So that one is important. It's gonna be also on Tuesday. You will also have the entire day to finish that. And the good thing is that you're not gonna have homework next week. For this one, you do have a homework, but for next week, you don't. So that's all the announcements for this week. Now let's get to work. The purpose of today's class is to discuss uh, the origin in your sketches. This is actually something that we have been doing in the past weeks by fully defining sketches, just using the Smart Dimension tool. Here I'm highlighting that whenever you're doing a sketch in a plane, you will have these two red arrows. They are placing the origin of the plane. So this point here where these two arrows intercept is going to have the coordinates 0, 0, 0. And then here in the bottom left part of the screen, we have the coordinate system or our reference. So in this case, I was in an XY plane. But remember that you can also be in a 3D space, an X, Y, and Z space. I would like to show you this trick on hiding and showing the primary planes. So you can be certain every time that you're actually drawing in a plane and not in a 3D space. So you just open SolidWorks, and whenever you have SolidWorks, you will have these controls here in the top. You just have to click in the eye icon. It's called the hide all types. And then in the arrow next to it, you will see that it will deploy all these options. The first one on the right is the primary planes. We'll see those primary planes right there. Now, I've seen that some of you are have been struggling Some of you have been struggling with the concept of hidden lines, and this is something that I showed today in the GroupMe chat. You can actually use SolidWorks to better understand this concept. And in this case, I did like a cube. I'm gonna just hide those planes. I did this cube, and then of course you cannot see the the lines that are between two faces are called edges. And of course, I cannot see the edges that are behind this figure. I will have to rotate it in order to see it. However, I can, here next to the eye, we have this display style option. We can go and select the fourth option there, hidden lines visible. And you will see that now I can see those hidden lines. Now, if for example, I do a hole in it, like this hole. It's just a circular hole that doesn't go all the way. It just goes up to a certain point within the cube. And then we activate the hidden lines. This will be the front view. You will see that the hole is hidden from this view. And that's why we have the edges of that hole and the bottom of that hole. I can also see uh, the side view and also the top view. And in the top view, since we have the hole in that face, this circle is not a hidden line. However, if we see the bottom view, it's going to be discontinuous because the hole is at the other side of this body. If I deactivate this again, you will see that the hole is in the other side. Okay, that was just a parenthesis showing you that you can do these hidden lines here in SolidWorks and that you can use this to do your homeworks basically for the lecture. Anyways, continue with our class. The objective is to always have present where the origin of the coordinate system is when you're doing a drawing, basically. If you recall, this is the blueprint that you did for the first homework, but in that moment, you just did the drawing and the drawing could be anywhere in the space. In this different case, I am specifying that the region is right there. So I'm gonna do an example. I'm just gonna do, maybe I can use this sketch. Okay, so we have our, our origin right there, and then I'm gonna draw a triangle, something simple. Now, of course, this triangle is not defined. I mean, only this line we know that is horizontal, and we know that this line is vertical. But we don't know the length of this line. We don't know the length of any of those lines. And of course, we don't know the angles within this triangle. The only one that we know is this one because this is a 90 degrees angle, right? Of course, you can use Pythagoras theorem to know all of this, and that's why I'm using a triangle because well, you're familiar with that. Okay, uh, let's suppose that I define all of these sides. And look, since I already have these two, with these two lengths, let's try this. I'm gonna modify this one to make it 4 millimeters, and this one is gonna be 3 millimeters. And therefore, if we apply Pythagoras theorem, we already know that this one is gonna be 5 millimeters, as we have here. Now, if I try to add one dimension more, it will be overdefined because with two lengths for a triangle, that's all you need to define the geometry of that triangle. So if by mistake, I click OK here, we will see that this dimension is driven, and that means that if I modify any of these two, the other one will be changed. But the one that is dark will remain the same. So if I try to modify this one, I cannot do that because this one is driven by the other two. So if I go and do this one 8, this one becomes 10. Okay, so that we know already that the even when we define the geometry of a shape, that doesn't fully define the sketch. If you see down here, we still have this underdefined, and of course, all of these lines are blue. Now, I've been saying that a good trick to know what you have to define is you can just try to move things around. But you see that when I try to move this, I cannot change the shape because the shape is already defined with all of these dimensions. So what happens if I delete one of those dimensions? I just leave this one. I can modify that shape. I cannot modify the length of the bottom, but I can modify this height and therefore this angle. So I'm gonna keep that distance. And we see that I cannot modify this geometry any longer. However, I can still move it around, and that's why it's still blue. Um, in order to have this fully defined, I will have to define also the position of any of those points with respect to the origin. Because if, for example, let's suppose that this distance, the horizontal distance, it's 5, and also the vertical distance is also 5. Now I know that to get from this point, the origin, to this point, I have to move 5 millimeters in the negative x direction and 5 millimeters in the positive y direction, and I will be in this point. And then from this point, I can go to either here or I can go either here because I already know those distances. So remember, in order to fully define a sketch, you need to define the geometry, as we did with these two uh, distances, but also the position with respect to the origin. If we don't have the position defined, we can still move things around. And that's why the drawing is underdefined. Okay, our next topic is gonna be um, how to add relations. I have also shown this in previous videos. Um, I'm gonna delete all of this. Okay. Um, if you see in this view, I am in isometric view, even when I am in the sketch environment. And I would like to highlight the planes now, because if I do, for example, a circle here, I will not see a circle. I will actually see an ellipse. And the thing is, I am watching a 2D circle from a 3D view. So that modifies the geometry. Since we want to do all of our sketches in a plane, that's why I wanted to show you how to hide or show those primary planes. So you can be certain all the time that you're in a plane. Because if by mistake, for example, I rotated this, of course now I'm not in a plane. And you can see just by checking this coordinate system here, you know you're not in a plane. So fast way to go back to the plane, because you can try to make your best and maybe try to align all of this, but it's really difficult. So what you can do is you can press Control 8 in your keyboard, and that's it. You are in the plane of the sketch. So I'm gonna draw this line and then I'm gonna draw an arc. Um, to draw this arc, I use the center point arc tool. Um, Sorry that I did that super fast, but I mean, the point is not to teach you how to do arcs, but how to add relation between two different kinds of lines. So you just have to go to, in the sketch module, you just have to go to the display and delete relations, clicking the small arrow underneath it, and then clicking the second option, which is add relations. When you add relations, as you see, sketch module, display delete relations. The second option is add relations. Here, the first thing that we have to do is select entities. So in this case, we're going to select this line and this arc. And you see that the possible relation between these two different kinds of lines are that either they are tangent, and that defines the position, or they can also be equal length. So if I modify, for example, the length of this one, let's suppose that it's 30 now, the arc is also shorter because they both are the same length just by defining this relation between them. And if I modify the position of one or the other one will also move because they both are tangent. So adding relations is another way of defining uh, a, fully defining a sketch. And this is how. For example, let's suppose that I want to add a relation between this point and the origin. Say that they both are horizontal. That's okay. Another way to add relations is just by clicking several things within the sketch and holding Shift in your keyboard. That way, both of them are selected, and we have both of them here in this list. And for this one, I'm going to define them as vertical. I can still move this around. So what I'm going to do next is I'm going to change this relation here. Instead of making them vertical, I'm going to merge them by defining that they both are coincident. And as you see, this line was defined just with its length and adding a bunch of relations. And we can do all of that with everything else. For example, in this case, I also define this circle just by adding relations. So this is another trick that you can do. Instead of adding a lot of uh, dimensions, you can also do some relations. Okay. Um, Guess I'm gonna skip all of this because I already did this exercise with the triangle, so I'm gonna just skip up to this part, which is the tolerances. This is something that I already showed before. You can do tolerances. The meaning of tolerances is that, for example, let me put here, I don't know, 2 millimeters. We can define, for example, when you are doing a drawing and then you're gonna manufacture your design, the person who is actually going to manufacture that, it's impossible to have a, with any manufacturing technique, exact distances or exact geometries. So it's not possible, for example, to produce I don't know, a cord that is exactly 30 millimeters long. There will always be some error, especially because if you go and measure that, Uh, Even with the device that you're using to measure anything, you will have an intrinsic error. So this is a way just to say, hey, the what I accept in the error of this 30 millimeters long line is 2 millimeters. So this line can either be 32 millimeters or 28 or anything in between, and I will be fine with that. Of course, having tighter tolerances, more exact dimensions, is more expensive. And that's why some industries like, I don't know, Formula One, aerospace industries are so expensive because they have higher tolerances. Now, uh, where do you use these kind of tolerances? Uh, gonna, these are some different representations of these tolerances. You have a basic dimension, and then you can have a plus or minus value. You can just have the upper and the maximum and minimum limit of of the measurement. Uh, the one that I just showed that is the called the symmetric tolerance, or you can have just a bounding values, a minimum value or either a maximum value. Those are just some examples of dimensional tolerances, but you can also have geometric tolerances. For example, um, if we go back and do the the circular hole that I showed at the beginning, I'm just undoing a lot here. And actually, I guess it's better if I just do this. Yeah, now I'm gonna just do it again. Uh, it was just a box and using an extrusion of this sketch. And then I draw a circle here, and then I extruded a cut. Now, of course, in a computer, it's really easy to draw a perfect circle and then do that hole there. But how will you do this hole in a real manufacturing technique? You will have to drill inside of this material. And using drills, of course, will not produce perfect cylindrical geometries. You will have some sort of error. Or for example, uh, this flat surface will never be flat. Uh, it will have some sort of roughness. And those are just some kind of geometric tolerances that you can also do. If you are welding, for example, two materials, there are tolerances related to welding as well. But I'm not gonna go too deep into this. I just wanted to show you uh, that it exists. It's something that you, as engineers, must know. You should go and read about it, especially if you are in a especially if you are in a technical drawing course. So this is just an example of a piston inside of an engine. Uh, of course, since you have these really moving parts that are so close between each other, you should consider adding some tolerances there. And actually, they do. This five type is another way of representing a tolerance, and there are tons of those. For example, in this one, you are accepting that uh, this surface and this other surface, the A surface and B surface, can be perpendicular with a deviation of whatever value, or that maybe the the shape of this circle can be modified or have a relative tolerance, a roughness of, I don't know, 0.015, whatever units they are using here. You can have tolerances in an angle as well. You can have all sort of tolerances. There are dozens of those. So just you go and learn some of those because they are really helpful. Okay, how to measure an angle? I guess I haven't explained this very well, so I'm just gonna do that again. Gonna delete all of this, and then I'm gonna modify this sketch. Control 8. Sorry, I'm gonna delete all of that. Again, I'm gonna draw a triangle. This time it can be any sort of triangle. And I don't know if you know, but if you add all the angles within a triangle, all of them should add up to 180 degrees. So if I define these two angles, 60 and 60, of course the third one is going to be also 60. But I'm just going to show you that as we did. So I can either define inner angles, or I can also define outer angles, like just by moving the mouse outwards. Now, 360 minus 60, of course, is 300. And that's what we have here. I can also do different kind of angles. Let me just delete this one. I can select. So the way to measure an angle is you go and click in the smart dimension. Then you click one of the lines of the angle and then the other one. And then you have just to move your mouse in the direction of the angle that you want to measure. I can measure the inner angle, the outer angles, or these uh, other angles outside as well. You just click where you want to place your measurement, and that's it. You can also use angles between, for example, a 3-point arc. And the way to measure angles here is just using the Smart Dimension tool. You have to first select the center, and then you select the other 2 points, and then you can measure that angle. You can do the same trick using circles. Maybe you want to define the angle between these circles, so you just have to select again the center of the arc, and then the other 2 points, and then you can define that angle. And then, as you see, they all come to the center of the arc. So whenever you are measuring angles, now you know how to do that. And I think, well, measuring diameters it's pretty basic. Just using the Smart Dimension tool, you click on a circle, and you can have the measurement inside or on a side, or maybe like an arrow pointing the center of the circle. All of them mean the same, uh, because this icon here means the diameter. So you're just measuring the diameter of a circle. So I'm just gonna skip that and move forward to the homework. Uh, this homework is gonna be due on Sunday at midnight, Sunday, February 14. Um, Remember that it's the same rules. Homeworks are due the midnight at the end of the week. Uh, Late submissions, of course, will have a zero, and that you will have to submit the SolidWorks part file and the PDF. And please try to use this file naming convention. It just makes things easier to file everything. So this homework might be a little bit tricky, but I'm gonna explain a few things here. So, of course, this is a revolution. It's a 3/4 of revolution, only 270 degrees. Uh, as you see here, I am placing the origin here in the center of this line and the center of this other line. That means that the x-axis is going to be this horizontal line in a front view, of course, and the y-axis is going to be this vertical line here. As you see, the sketch is at 20 millimeters away from the x-axis, and that's what produces this circular hole here inside of this pulley. You already know how to measure angles, so this is not difficult. And the angle in this case is measured between this diagonal line and any vertical line. If all of the vertical lines are parallel, then measuring an angle between this line or any other vertical line is the same. So you can use any vertical line. Now, for these other diagonal lines that you have here in the pulley, all of them are at 62 degrees from the horizontal. So any horizontal line that you want to use is the same. A trick that I recommend you to use here is that, as you see, of course, a belt will go around this pulley. So all of these teeth must be the same. And therefore, all of these lines are parallel between each other, and also the diagonals that are going in the other direction. You can assume that the lines in the bottom are also the same length. All of them are these 10 millimeters. But an important thing here is that you don't know the length of the lines in the top. You will actually get them by construction. And that means you will not have to define them. Yeah. And still, this will be fully defined. So I don't think uh, it has any other complication. Just the total diameter of the entire pulley is 360 millimeters. Uh, as you see, this arrow like goes, but then it's cut here. This means that it's an entire diameter. And the same for these 40 and 108. This is the inner diameter of this hole, and this is the outer diameter of this. Let's call it an extrusion, a cylindrical extrusion. Uh, that's it. Uh, the As you see, all these lines in the bottom are 10 millimeters. So just keep that in mind. And I think that should be it for this homework. Please let me know if you are running into problems on doing this homework. We can meet on Thursday. As usual, I will have my office hours from 10 to 12:45, and I can try to guide you through the process of doing this homework. Okay, thank you very much. Have a good rest of the week and see you next week. Bye.